Hello, everyone. Welcome to our first webinar in 2026, from engineering as usual to autonomous AI agents. So my name is Mike Rao. I'm the head of pre-sales here for Agentic Engineering at Synera. I've been with Synera now for the last 3 years, but my journey spans over a decade in the software industry. So I've specialized in process automation, generative design, and advanced design approaches. So I'm a mechanical engineer with background in automotive design, but I'm excited to bring this perspective today to this session. So today, what we want to cover is pretty much three key areas. First, we will begin with a big picture overview, what the industry status quo is, the challenges we face, and how agentic engineering changes this. Second, we will see a multi-agent system live in action, and then I'll show you exactly how such systems are built live inside Synera. And finally, we explore tool workflows and how you design them and how they fit into the agentic system architecture. So as we build these multi-agent systems and the workflows, any misconceptions you may have had will disappear and you gain a clear insight and comprehensive understanding of how the system works. And at the end, we will have 5 minutes for Q&A. So I would say, let's start it. Okay, so the status quo. And why do we need agents actually in the first place? So imagine a company that manufactures gearboxes. For each design iteration, experts have to collaborate. They're also involved in other projects, get sick or go on vacation, eventually have to write and read reports. But not only that, in a perfect world, teams work in parallel. But the reality is a lot processes are sequential. But that brings a huge challenge. Teams have to compromise on design performance and cannot explore innovative ideas. So the result, project timelines slip and exceed budgets. So what if you could overcome this bottleneck with an army of agentic engineers, right? First, they would communicate with the human team members in natural language, like you communicate with your team member. And second, they will act like real engineers, create designs, run analysis, follow requirements. They execute the repetitive tasks in milliseconds for you. So with agents collaborating around the clock, you gain transparency of your product costs, so giving you a whole new level of real-time understanding. Within this multi-agent systems, the roles will change. Humans focus more on creativity and decision-making rather than executing tasks. So this will become a true game changer, and that gives you a competitive advantage. So looking at this right now, do you know what an agent is? And have you heard of it? So I'm really curious if you have heard of agent, if you have familiar with agents. So I want to ask you to scan that QR code and submit your answer. And I will hold this slide for about 60 seconds or 1.5 minutes, and we'll see what you may come up with. So I'm curious because agents are new and not everyone had the chance to really work with agents and look at them. Okay, so the response is coming in. I'll just wait a few more minutes, seconds, and then let's show the responses. Okay, this is a good turnout. Okay, somewhat familiar is great. So half of you already know about agents, and that's great. So of course, the pressure in the industry really forced you to look at that. Yeah, so good starting points. Now we're just ready to deep dive into agents, and yeah, let's get it started. So what we think an agent is, and let me explain this to you in a few simple words, is that an agent already consists of a chatbot. A chatbot is nothing else like a ChatGPT, Claude, Llama, any large language model you can think of. But an agent also has access to instructions, knowledge, and memory. And let me clarify that. Instructions are clear role definition. So for example, if you have an agent that executes an FEA job, you clearly tell them what his job's duties are. Knowledge, on the other hand, is your intellectual property. So you as a company have a database of knowledge and you share this knowledge with the agent so the agent can access that knowledge. And memory is what improves the agent over time. So anytime you execute a workflow or a task, the agent learns from the answers and your requests. And last but not least, very important, tool workflows. Tool workflows are a digital representation of your processes. They encapsulate all the tools that you use on your daily basis, from NX to Altair to Excel, and build a logical process. And the agent has access to this logical process. So now you asked me, what's the difference now between tools and agents? So let's look at this. Today, CAD kernels are still the engine of the 3D programs. So many of these tools cannot be automated easily. So work happens across license servers. Physics simulations can take up to 6 to 8 hours. So what does that mean? Physics simulation can take up to 6 hours, but these 6 hours do not run on your local machine. They actually run on large compute farms. So what happened? The established software vendors built a large ecosystem over the last decades. They were not designed with the intention to talk to each other. They created somewhat closed environments, really hard to escape. So companies use every tool that they can access to get the job done. They are use case focused, not platform focused. So with more than 1,000 different use cases in the engineering field, this becomes a really problem. So just give you an idea. A typical OEM uses around 500 to 800 different tools across the development process. So this is a big problem for the industry. But how would you overcome this problem with agents? And that's a big question, right? So first, our customers use single agents. They create these single agents and then they combine them into multi-agent systems. Here, for example, we have a supervisor that is in control of a small team that has a design agent, simulation agent, and a cost agent. Second, they build workflows for these agents. So each of these agents has access to the workflows as I described them, and the workflows execute a task. But not only that, through the workflows, the agent can run tasks in the third-party software. So that means they have access to all software from all vendors, and they're not limited. And this is really making these agents unique. So let's see how we build an engineering system live. And the first thing I want to show you is how this multi-agent system is in action. So as you can see, I have shared the overview with you. Now let's switch over to a multi-agent system. And I'll share my screen in a second. And here we have one of those multi-agent systems live in action. So this is a multi-agent system that I name Digital CAE Coworker. The objective of this multi-agent system is clear. It has to process CAD data. It has to simulate a part, so run an eigenfrequency analysis. And it also has to create images. So what we're going to do here is pretty much we have to provide this supervisor or this agent with geometry and then give an instruction. So what we can do now is we can just ask it, can you run a model analysis of my part? And of course, we have to provide a part. Let me just find that one. The one that we want is this one. Now we let the node upload. And we prompt it. So now you see the supervisor starts working and he's trying to process our language input. And the next step, he's already calling the 3-shaft gearbox eigenfrequency agent, who's pretty much taking up the task to simulate this part. And now he's going to run the simulation live on the server. So he's opening a software tool like an X, he's importing that, modifying a few parameters, and then he's processing data. He's going to mesh the part and run a Nastran solver in the background. So we will revisit this multi-agent system in a minute. Now let's go into Synera, into the developer environment, and see how it's actually built. So I'm going to stop sharing and switch over to Synera. All right. So here we are within Synera. This is the Synera editor, as we call it. This is where you build a multi-agent system. And what we would do first is we would bring in a team agent leader. So let's find that agent. we want. And that's pretty much the agent team leader. I have pre-built this node for me out of convenience because I use it quite often. And that team leader or supervisor, of course, has access to a large language model. In our case, this is Claude Anthropic. And this supervisor has, of course, also instructions. I'm not going to fill them out right now, so they're pre-filled. And what this team leader now needs is agents, right? So the first agent we're going to bring in is a sales agent. And the sales agent has nothing else to do than create nice images, because once we send out a quote to a prospect, we want to make sure that we actually have nice images. So what we miss here is, of course, the large language model. So every agent has to have access to the large language model. So now we just drag a wire down from here, plug it in, know the screen, and we hide this wire. Done. So this supervisor now can communicate with the agent. And what is really clear is that the agent has also access to a workflow. So if I open that drop down here, you can see a number of tool workflows that are actually running on our server right now. So I can assign only one tool workflow to that agent, or I can assign multiple workflows to that agent. So agent have access to any workflow you want them to have access to. So we need a few more agents. Of course, we need one FEA agent that we have to bring in. And we do the same as before. We'll connect the wires, assign an LLM. That's done. And we hide that a little bit. And we also want to bring in a cost agent, right? So here's the cost agent. We connect the wires again. And this time, maybe we want to use a different LLM. So we just type in large language model, use this node, and maybe use GPT 4.0. So the large language model you're using here can be online or offline. It really doesn't matter. We are agnostic to any. And since this is done now we can publish this large language model, this multi-agent system model to the server. What happens now here is we actually have to give our workflow name. So we call it digital CAE coworker. And give it a description. It's like run modal analysis. And of course, we would have to give a more detailed description. So now we could publish this multi-agent system to the server. And this is pretty much what you have seen just a few seconds ago when I prompted the multi-agent system. So now the question is, as I said in the beginning, we have multi-agent systems. What else do we need? We need tool workflows. And what is a tool workflow? And the tool workflow is nothing else than a digitalized process that you have defined. So let's just build a tool workflow for this FEA agent. A simple FEA workflow that takes in the part and runs a modal analysis. And for that purpose, I've chosen a more simplistic part. So the first thing that we need is an input relative file path. So now we'll just import this part, which is an AX file, and you see it's very simple. It's just a bearing mount, but that's good enough for now because this is agnostic. So whatever geometry comes into this workflow, it will run through this workflow. If it's a bearing or if it's a gearbox, it should run both. So first, what we want to do is we want to use these green surfaces and use them as a constraint for the modal analysis, right? In order to get these green surfaces, we have to filter the attributes. So we drag another wire, filter the attribute value, and the attribute value we want is the color green. Change the RGB value a little bit so we hit the right green tone. And voila, here we see these surfaces that we want for the constraints. So what else do we need? Maybe we need to clean up our file. So we see there's one solid body in our file, but a lot of curves, and we don't need these curves. So let's remove all these curves. And therefore, we use this remove null nodes, remove nodes that I've created. And hurry, I will find it with a number that's better, 1806. So let me just take a look how I named my own workflow. It's called 018, right? Okay, here he is. Here we got it 018, and then we have a bunch of different remove nodes. That's the node we need. And now a solid clean body is coming out. Now we can use the solid mesh node from HyperMesh and just plug this in. So one thing is of course missing is the element size. And the easiest thing here is just to use a node that I created to measure the bounding box of the pod and determine the element size. So very easy. Again, we get this node that we want. It's this node here and job done. Oops, wrong wire. That's the right wire. And now this body will be meshed by the helper mesh node. Last but not least, we still need a node that runs the modal analysis. So we will run a solid mesh node that runs a solid mesh and constraint surface. So just select the solid mesh, plug it in, choose geometry constraint surfaces, and run the simulation. Et voila. And we have our results. So our result is right here. It says that first node mode has 994 hertz, and we ran the part in aluminum. So if we switch back now to our multi-agent system, you see exactly the same that happened. And let me just jump over. So our multi-agent system already finished. It ran the same workflow that I have built, but of course with different results. First mode with 369 hertz and with a different geometry. So this is really the power of agents. And what I can do now is also I've defined a cost workflow in the past. So now I can ask it, hey, can you calculate the cost of my design with steel as standard material? So the agent goes back, asks the supervisor, going back and forth, trying to find out what's the current market price for steel that we have chosen in a simulation, and then provide a cost number. I have already asked it that before because it calculated that the material cost is approximately €1.50 per kilogram, which is just an approximate value. Now we have a mass of 729 kilograms. So we have a really large gearbox and a heavy one. And the cost is about €1,094. So this is how agents work pretty much in a nutshell. And of course, this agent is still running, compute calculating cost. And I would say we can wrap it up now and jump right into our Q&A session. So let me share my screen again and we'll just get right back. Okay. So, and if you're interested in any other Agentic engineering session, there's a future engineering summit coming up where Synera hosts or promotes, and we also have more upcoming events on our website. So looking forward to see you there, and I would open up the questions to the people. Thank you for listening. Okay, so we have a few questions in the chat. Okay, so here's one question from Dave. How smart is each agent, for example? How does the simulation agent know what the boundary conditions are? How does the cost agent actually calculate the cost? Yep, as I explained, so the boundary conditions are pretty much defined through a workflow. So we have to define a certain logic in order to help the agent pretty much to understand where boundary conditions are. And costs are usually generated either by, believe it or not, Excel sheets or SAP integrations. So the workflow can have access to SAP, for example, or to an Excel sheet that provides real-time cost. Yeah, what differentiates your platform from other platforms like NNN or Stack AI? Good question, very good question. One of the key differentiators is actually that we're using a solid cat kernel in the background. So we're using a the Parasolid kernel in the background. And that really allows us not only to process CAD data, but really run logic on top. So pretty much we're connecting to other tools, but we can also process data based on real geometry. Yep. What security controls and compliance frameworks does Synera support? Good question. We are TSAC certified. That's the first thing. But when it comes to really the Synera platform, you can actually put passwords on your workflows. But since everything is locally, so we're not a cloud-based platform, you would pretty much rely on your security infrastructure. So we have authentication through Assure that we offer. So there's a lot of things that you can do. Uh, a lot of questions. I'm scrolling through it right now, so please give me a second. Yeah, okay. How can we vary the loading condition at different analysis types of the same model? Yeah, that's quite interesting. So I do like to have a lot of control over that. And what I've been doing in the past, I actually build text prompts. So the input of a workflow is a text prompt. So it's not a fixed integer. And I can tell actually the agent, hey, use a 500 Newton load. And then it would convert that 500 Newton load input through the command panel into an integer input in the workflow. So you could do it this way, or we can predefine it. Um, Okay, what else? You mentioned on your side that you are token based. How could the cost look for me as a SME? That's a good question. I mean, we're an agentic company, so it means that we are rolling out a strategy for the companies we work with. So basically, tokens um, are calculated by the number of users and the number of workflows that you have to account for. Um, Hard to say. It's pretty much range from 30,000 to 200,000 tokens. It really depends on the workflow. Okay. What about the interoperability with agentic AI solutions from other vendors? Do you support A2A protocol or other standards? Yes, good question. So we are working on the support of the MCP protocol, and this is a primary focus pretty much for us. And yeah, so I'm going through all these questions step by step. I hope I can answer all of them. What about can an agent generate a drawing for a 3D model? Agent cannot do that directly, but you can definitely build a workflow that can do that. So you can ask an agent to create a drawing from 3D model for you, and then the agent would have access to multiple workflows because it would know what tool, so what 3D tool it has to use, which engine it has to use. So yeah, that's possible. Um, I'm interested in the analysis requirements of RFQ process. Is agent available for this test? Yes, this is a great question. This is pretty much the low-hanging fruit for all companies right now. This is the highest pain point, request for quote process. And this is pretty much what Synera is focusing on right now heavily. So pretty much every request we get from prospect is about RFQ. And that's primary focus for us right now. Yes. So agents are meant to do this. Uh, so happy to have a deep dive with you. Would your models be able to help me create optimization for parts? Yes, actually, they do. So you can use Synera's backbone engine to run optimization schemes or connect to other optimization engines. But you can also use an agent as an agent optimization engine. So I tried this in the past. It works. Pretty much skip the whole optimization DOE logic and just allow the agent to control all parameters of a given workflow. And actually, it would function as a, interactionable optimization engine. Really interesting. Um, okay. Where can we find a list of all third-party apps that you can integrate using the agents? For e.g., what solvers can the simulation agent call up in? A good question, Jave. We have a marketplace. Maybe I can just pull it up and show you where that is. Now you should see my screen again. So this is pretty much our website. And this is what you can see is the portal. Pretty much once you log in, you have access to all the content. And in our portal, you see one feature is called Marketplace. And within the Marketplace, you find all these add-ins and tools that we connect to. So pretty much third-party companies. And yeah, just take a look, browse through it, search for a specific category. If you can't find it yet, maybe ping us. We are constantly adding new features and add-ins and connectors and modules. So if it's not there, we may be already working on it. Or if it's something that we don't have on the radar, we're really looking forward to hear from you about that. Okay. More questions. Let me see. Where do we stop? Okay, do you have a management and release process in place for agents that ensures their valid and approved use? Since you build agents yourself, you are in charge of this approved process. So what I would recommend is that you actually have a password um, behind your agent system, and anytime you um, publish an agent system, it's your name behind that agent system, so you're in control what will be released. So not a good idea to have a single point of failure, but maybe two or three people should have access or admin rights to an agentic system. So how do you do data security on LLMs? Does LLMs provider have access to data? Yes, good question. A lot of our prospects actually and customers use local LLMs, so they pretty much ring fence the information that will be fed into the LLMs. And there's a server, of course, where the multi-agent system runs, and all chat information, so and data you upload, like that file that upload, will be stored in that server, but it doesn't leave your company, right? So even if you use an open LLM like ChatGPT that's cloud-based, you never send any data out to that LLM. Um, it always stays in your environment. Thank you very much, and I really appreciate it presenting to you how agents work, and looking forward to see you in the future somewhere. All right. Thank you. Have a wonderful day. Bye.